Hello, my name is Mallory Rivero, and I will be presenting our physics project. For our project, we mutually decided to demonstrate the contrast of the acceleration between different angles using a skateboard and various inclines around the ASU West campus. To analyze each video for acceleration, we used the video analysis tool. Here we have our video number 1, which has the angle of 1 degree. As a group, we decided to plot the points at the same place, which was at the tip of the skateboard as it went moving so that it would allow us to determine a position and velocity versus time graph. And this was applied to both of our videos. Here I will play this for you really fast. Here we have our position versus time graph, which has a positive slope with a constant velocity that is also positive. And here we have our velocity versus time graph, which is also positive and has a constant increase in acceleration. As you may see, there are some points that are below the linear line, which resulted from some bumps that the skateboard experienced while going down the ramp. Once again, as a reminder, we decided as a group to plot the points at the same place, which was at the tip of the skateboard, and here we have angle of 20 degrees. Here we have our position versus time graph, which is also a positive slope with a constant velocity that is also positive, but the slope here is slightly higher, which indicates that the slope is steeper. Here we have our velocity versus time graph, which is also positive and has a constant increase in acceleration, but it is less steep than the other graph and has a lesser slope. Here we have how to calculate the expected acceleration. We use this formula: acceleration equals g times sin theta. And for g, we use 9.8 meters per second squared, which is the acceleration due to the gravity near the Earth's surface. And of course, for sin times theta, we use the angle that we found, which was the angles that we used. And for angle 1 degrees, we implemented our numerical value to receive 0.16 meters per second squared. And for the 20 degrees, we implemented our numerical value and received 3.35 meters per second squared. Here we have how to calculate the observed acceleration, and we use this formula, which was the final velocity minus the initial velocity divided by the time change. And for the 1 degree incline, we inserted these numerical values and received 0.125 meters per second squared. And for the 20 degree incline, we, of course, inserted these numerical values to receive 3.63 meters per second squared. Here we have a comparison of the expected and observed accelerations. Of course, we use the observed acceleration, which was 0.13 meters per second squared, and 3.63 meters per second squared, which was the numerical values that we just received, and use the expected acceleration, which was 0.16 meters per second squared, and 3.35 meters per second squared. And to receive the percent error, we use the absolute value multiplied by the observed minus the expected divided by the expected. The absolute value was multiplied by our expected value and minus our observed divided by our expected to receive 18.75%. And then we did this for also the 20 degree angle and received 8.36% error. Thank you for watching.